Bismillahirrahmanirrahim. Assalamualaikum. Good morning for the all participants in this room. We will try to continue our discussion about the new models in the Rado Institute, of course. For this time, we will try to talk about the third model. This model is created by Rado Institutes. We give name, this model is the inverse power Rado Institute distribution. Okay, so it's mean Rado Institute have created the three model. The first model we call the Rado Institute distribution. The second model we called Power Rado Institute distribution. And the third model we call Inverse Power Rado Institute distribution. Okay. For the first session, we will talk about the probability density function. Of course, maybe in the next session, we will try to talk the some properties like the cumulative, first or second moment, the survival, and the hazard function. Okay. The inverse power Rado Institute distribution based on the theory transformation random variable. Okay. From these books, the candidate books, I mean, we have written about the theory of the inverse power Rado Institute distribution. Okay. If the random variable y with the power Rado Institute distribution with the density function Fy equal to this one, you can see from your laptop. Okay, and then we will try to make the random transformation, the random variable transformation with x equal to 1 divided y. Y is the power Rado Institute distribution random variable. So the first one, we must take the inverse. H inverse x equal to x power minus 1. And then we try to make derivative of the inverse of h. The inverse of h, we try to take the derivative to x, is become minus x power minus 2. Okay, based on the theory of the random variable transformation, we can find the new density function with the Fy h inverse x multiplied by the absolute the derivative of the inverse x to x. Okay. So this one, it's mean the x in this y, okay, this y is mean the random variable y on the power Rado Institute distribution. I mean in this one, the y we change by the inverse of x. We change by inverse of x. So we multiply by the absolute of the derivative of the inverse x. So we can find the new density function, the namely inverse powers Rado Institute distribution, like this one. Okay, like this one. This is the density function of the inverse power Rado Institute distribution. So, of course, after we have the new density function, namely the inverse power Rado Institute distribution, we must try to prove the integrate this density function starting the 0 until infinity must be equal to 1. Okay, must be equal to 1. So, of course, we try to prove the integrate, okay, like this one. We try to the integrate, okay, you can check on this candidate books, okay, like this one. This is integrate, okay. This one is the inverse power Rado institute distribution. Of course, this one is very easy. Okay, like this one, very easy. Okay, so after that, we try to divide this integrate become to the three partition. Okay, this is the first partition. Okay, this is second partition, and then this one the last partition. We take this is called the constant, of course. The constant, of course, if the constant, we can put in the outside of the integrate because it's a constant. So to make the success to prove this case, we will try to just solve the one by one. Okay, the first time we will find what is the integrate of this partition in the first partition, like this one. Okay, before we find this integrate, we need the sum component, like this one. We take the nu equal to x power minus alpha. Okay, x power minus alpha using the nu. Okay, of course, if we have nu equal to x power min alpha, so x is equal to nu power minus 1 divided alpha. And if we take the derivative from the two sides, we give derivative on two sides. Of course, d nu equal to minus alpha x power min alpha minus 1 dx. So after we use this component, we try to solve the integrate of the first one like this one. Okay, like this one. We change x become the nu power minus 1 divided alpha, power minus 1 minus alpha, exponent min theta nu, d nu divide by minus alpha, nu power minus super alpha, power minus alpha minus 1. So you must be careful. You can check this one. The limit of the integrate is not 0 until the infinity again, but changed by infinity to 0. This limit because this one. Okay. If we are talking in the x random variable, of course, the limit 0 until infinity. But if we talk about the new random variable, the limit is changed by the infinity into the 0. And then we try to using the simple technique in the calculus. We put minus here, so we change the limit again until we change the limit again, starting to 0 until to infinity. This one is simple calculus. This calculus say if we put the minus here, you can change the limits. Okay, you can change the limits. So this is the minus. This is the minus. So minus multiplied by minus become to the positive. So in this one, there we can cancel the minus. Okay. So this integrate is so very easy. We put the 1 divided alpha in the outside because this is constant. We just have only the integrate nu power 1 minus 1 exponent minus theta nu d nu. This is very easy. By using the definition of the gamma density function, we can conclude that the integration only 1 divide alpha multiplied by gamma function 1 divide the theta power 1 equal to gamma function 1 divide by alpha theta. This is the solution of the integrate in the partition, the first partition. Okay, this one, the solution of the first partition. Okay, next. We have success to solve this partition. So next we try to solve this at this integrate. Okay. So we use the same way and then the same component. Okay. we have this one integrate. This is for the second partition. Like I said before, be careful with this limit the integrate, put minus here, and change the limit again, starting 0 until to infinity. So you have this integrate. So it's very easy. Okay, this is very easy. So we have this one is minus. Okay, this one is minus. I mean a minus, and this one's minus. So we can cancel the minus. Okay, we cancel minus. Put the constant in the outside. So we only have the integrate starting 0 until infinity. Nu power 2 minus 1 exponent min theta nu. And then you can use the properties of the density gamma density function. So this one, this integrate, if we try to using the gamma density function, you can find the solution of the integrates only gamma function 2 divide the theta power 2. So the solution of the second partition only gamma function 2 divide alpha theta power 2. And then for the third or the last partition, okay, this is the last partition, okay, you change the x by this one. So you must remember our integrate starting infinity until 0. Use the simple mathematics, put the minus here, and then you change your limit. You can find this integrate. So remember, this one is negative or minus. This one is a minus. So we cancel the minus. So the integrate, we put this 1 divide r in the outside because this is a constant. We only have this one, the integrate. The integrate starting 0 until infinity, nu power k minus 1 exponent min theta nu d nu. Use the density gamma function. You can find the solution of the last partition is the gamma function k divided by alpha multiplied by theta power k. So after we are success to solve the all partition in this case, we try to use in like this one. Okay, this one, this partition in this one. Okay, the second partition, this one, and the last partition, the integrates only this one. Okay, so using the simple algebra or the simple mathematics, you can find this one. Okay. You take the alpha theta power k in the outside, and then of course this is this is very easy to understand. So you can see here the last proof, the last equation only summation I starting to 1 until k gamma function I multiplied by theta power k minus I divide summation I equal to 1 until k gamma function I multiplied by theta power k minus I. So it is the same, okay, the same form, same function, okay. Of course, we have success to prove the integrate of the density function equal to 1. So it's mean, okay, it's mean this function, okay, this function, we have said before, this is the inverse power Rado institute distribution. It's a right function. It's all right function. Because we can prove the integrate starting to 0 until infinity is equal to 1. So I think our discussion today is a very good discussion. We can find the others probability model, namely inverse power Rado institute distribution, only by using the transformation variable x equal to 1 divide y. Y is the random variable for the power Rado institute distribution. So you using the technique of the transformation random variable, you can find the new model, namely inverse power Rado institute distribution. Okay, I think that's enough for this time. See you again in another time, Rado and Rado Institute. Assalamualaikum warahmatullahi wabarakatuh.